Basically, Impulse technology provides cutting technology for the next generation, nanoscale material, and the device for a semiconductor device also, and for a quantum technology like for the spin qubit devices, for superconducting circuit also, and for the solar cell. And we are partner with three companies. First one is Fluxim, which is a Switzerland-based company, which offers several software for solar cell and photovoltaic device, OLED, and semiconductor technology also. And the second partner is Nano Academy, which is a Canada-based company. They offer several software for the atomistic and quantum simulation tool, which is used for like material, nano device, and for the spin qubit devices and superconducting circuits also. And third one is HZW, which is a China-based company. They offer several software for the quantum chemistry, DFT-based software, and tight binding software. You can see the product list also. Like here, you can see the SetFOS and Laos, which is from Fluxim, which is used for the solar cell, OLED, perovskite. And you can see the nano decay, which is used for the nano devices and material both. It is based on density functional theory and non-equilibrium being function. And you can see the rescue software also, which is used for the material simulation. QTCAD, you can see a QTCAD software, which is used for the spin qubit devices and superconducting circuits also. And nanoskim, which is used for the tight binding method. You can see the DS-PAW also, which is used for the plane wave and TFT-based software for the material. You can see the BDF and MOMAP, which is used for the quantum chemistry. And you can see the our customer list also, like NICE, BIT Vellore, Triple IT Allahabad, SRM, IIT Bombay, Madras, Dhanbad, and many more. Let's talk about the first software, which is the SetFOS software. SetFOS basically is used for the organic and perovskite solar cell, photodetector, and LED. It comes with the 5 modules to simulate light emission, absorption, scattering, and charge transport. Like in absorption, you can find absorption profile, ideal JV curve, energy yield analysis, and in the second module, like drift diffusion module, you can find electronic charge, excitation, ionic charge, trap, DC-AC transient solver, polar layer you can find. In advanced optic module, you can find conversion and particle scattering, scattering at textual interface you can see. At the emission module, you can find model analysis, quenching, coherent, incoherent layer also. And in the thermal module, you can do OLED degradation analysis, optical heating, and thermoelectric effect. You can see the result also, some of the result attached here, like the structure layer you can see here, emission spectrum, and configuration you can see here. Same from the Fluxim, the second software, which is Laos, which is used for the large area semiconductor device. It also comes with the 3 module, electrical, thermal, and optic module, where you can optimize your electrode design, reduction of the electrical losses, and understanding electrical crosstalk in OLED pixel array. And you can see that in thermal module, you can calculate the temperature distribution in OLED solar cell under standard operation also. And in optic module, you can find crosstalk in OLED display, and you can optical simulation with the 3D ray tracing algorithm also. And you can analyze like electrical losses in large area electrode, calculate IB curve for the large area devices, optimize the power efficiency for the full solar cellular module, and pixel crosstalk effect you can do, optimize the geometry of the electrode, and impact of defect and stunt of the device operation also. And the third software, which is OPC software, which under the Fluxing, which is used for the like pixel array. You can see, you can find power consumption and tool for the pixel design called OLED, QLED, micro LED, and for the advanced display technology, where you can find like efficiency and other parameters are like power consumption and if like form factors, sub-pixel ratio also you can find. Like you can see here also for the pixel design and power consumption. And you can see the RGB analysis also here you can see. Now let's see the product list for the Nano Academy. Here you can see the QTCAD, which is quantum technology computer aided design tool, where you can simulate spin qubit devices, superconducting circuits, and you can use like finite element simulation for the superconducting circuit and find Maxwell eigenmode, capacitance matrix, and other parameters also. Like in QTCAD software, you can simulate spin qubit devices and superconducting circuits also, like using the atomistic modeling, quantum transport, and other parameters also. Like you can find quantum dot, adaptive meshing algorithm, Maxwell eigenmode, and you can visualize also to the quantum builder. Now here you can see the Device Studio application. At a single platform, like Device Studio is GUI, at a single platform you can do quantum chemistry, material-based simulation, and device both. Like in Device Studio, you can do the quantum chemistry calculator using PDF also. MoMap, which is also used for the quantum chemistry calculator, for a transport properties calculator. Here you can see the DS-PAW software, which is used for the plane wave material-based software, and the RESCU you can see for the material-based. It means at single platform, you can use PDF also, MoMap, DS-PAW, RESCU. But in this license file, you can use only the RESCU and DS-PAW. But at single GUI, you can do the quantum chemistry also, material also, and nano devices also. Here you can see for a nano device, you can use the nanodecay software, which is based on density functional theory and non-equilibrium gain functions, where you can use for the creating the nano devices like left electrode, right electrode region. And you can see the nano scheme, which is a tight bending quantum transport calculator also. It means at a single GUI, you can use uh, DFT-based software, quantum chemistry based software also, and point defect software also. And it also GUI for the, like you can see the quantum espresso and for the WASP and other quantum chemistry software. Only GUI for the other software like quantum espresso, WASP, and Gaussian. In today's session, basically we go through the rescue software. Like rescue is based on the DFT based concept DFT solver, where you can simulate like organic or you can find Raman properties, optical properties, boundary condition. You can do electronic structure, structure relaxation, mechanical properties, and you can include the density functional perturbation theory also. Like it is based on density functional theory and density functional perturbation theory. Like in density functional perturbation theory, you can find dielectric tensor, optical properties, phonon, Raman tensor, electron phonon coupling. You can do like in structure relaxation, you can do with through the quasi-Newton, conjugate gradient, step and descent method also. And through the magnetic properties, you can include collinear, non-collinear, and spin orbit coupling. In electronic structure, you can find band projection, Dawes projection, Mulliken charge, band unfolding. In boundary condition, you can find periodic boundary condition, open, external Dirichlet, and in rescue software, you can also include Hawardian term, and it comes with the exchange correlation function like HSC06, hybrid exchange correlation function, LDA, GGA also, and it is based on MATLAB. It means some of the output has been shown in the MATLAB. You can see the application case also like more pattern simulation. You can create this type of pattern in the Device Studio GUI, and you can simulate through the rescue software. Rescue is used only for the material simulation, where you can use the hybrid exchange correlation function, GGA, HSC6, and multiple exchange correlation function you can use, and you can find other properties like dielectrical, optical, phonon, Raman properties you can find. You can see some of the result here also, like career mobility simulation through the rescue software. You can see some of the results have been attached from the paper using rescue software. And you can see that for the graphene here, you can see twisted graphene layer. You can also create in the Device Studio GUI. Same for the density of state, charge transfer simulation also. And same for the water molecule dipole analysis and differential charge analysis also, differential charge analysis. Here you can see also for the carbon nanotube, band structure you can find in the rescue software. You can also do for the band projection, band unfolding. You can find Berry curvature also, uh, scanning tunnel microscopy. You can do response theory related calculation. You can find IR intensity, Raman properties, dielectric constant, and other parameter you can also find in the rescue software. In the upcoming version of a rescue software, we introduce AI for the lattice principle. You can see here lattice mind. Through the lattice mind, you have to define your research project. it basically generates your structure. After that, it automatically create your input file with the suitable parameters. Like in the current scenario, you have to enter the cutoff factor, k point value, and other value also. But in the lattice mind, you can go through. Only you have to define your project idea. It automatically create your structure. After that, it will create your parameter and input file, like configure and tuning validation. First, after that, here is a human intervention. Basically, you have to see the your input parameter, then you have to execute and validate, and it will create your analysis and report also. It means you have to only define your project idea here, and it automatically create your structure. Then it will configure your parameters also and create your input file. And here is the human intervention where you have to check your input file. Then after that, you have to run your input file, and it will create your report also. Like here you can see, basically normal DFT tool, you have to read multiple research paper, decide parameter, build atomic structure, write input file, run simulation. But through the lattice mind, you can easily go through this. You have to only define the research project here, and it will automatically create your structure and parameter for the input file also, and it will create your report and the result also. To the lattice mind, you can see the process here, like project proposal. After that, it will go through the supervisor agent and create your literature research, workflow planning, and it will configure your parameters. After that, it will generate a structure. Then it will create your rescue input file, like SCF input file, band structure input file, DOS input file, and you have to see your structure parameters. Once you confirm, it will execute. Here you can see human approval. After that, it will show the result, and you can generate your report also. It means through the lattice mind, you have to only define your project proposal, and you can go through AI basically here. Like you can see the understand your goal, prepare everything automatically, run the simulation, and give the result. And the second software in the Device Studio GUI is a nanodical software, which is used for the nano devices and material both. It means at nanodical software, you can simulate material also and a device also. It is based on density functional theory and non-equilibrium gain function. It comes with the, like, you can find mechanical properties, thermoelectric module, electronic module, phonon module, and you can include also like spin properties also. Like in mechanical property, you can find Poisson ratio, Young modulus, atomic stress, strain you can do. In thermoelectric module, you can do like thermal conductivity, lattice thermal, Seebeck coefficient. In electronic module, you can find SCF, total energy, band structure, PDOS. You can see the IB curve, photocurrent, charge, eigenstate. You can find AC transmission spectrum, mobility of electron and holes, mean free path. You can also do thermal current, and you can see the result here, like biomolecular devices. You can create this type of devices in nanodical software. Like this is a left electrode region, center region, and right electrode region, and you can find the transmission properties also at a different angle also. Here you can see the some paper related to the nanodical software, like for the gate control quantum interface effect in single watt carbon nanotube PN junction. Basically created a device like left region, right region, and center region, and find the properties also. Same for the two-dimensional flexible devices. You can create a flexible devices in GUI also of a device studio. Same here you can see biomolecular devices. These type of devices you can create in Device Studio, and you can simulate through the nanodical software also. Like for the gas sensor also, and you can find thermoelectric performance research also. Like you can find thermoelectric property, Seebeck coefficient you can do, and other parameter you can find through the JT also. Now let's talk about the third software, which is a DS-PAW software. It also see in the Device Studio GUI, where you can find electronic structure, structure evolution. You can find magnetic properties, linear response, optical, and in electronic structure, you can find DOS, ALF, P charge, partial charge, band unfolding. It is based on plane wave, Basically, DS-PAW is based on plane wave, where you can find electronic structure evolution, magnetic property, linear response. Like you can find elastic properties, boron effective charge, AIMD you can find, optical, NEB you can do in the DS-PAW software. And you can find these type of properties also, like TDOS, PDOS for the different material. Same, you can do the charge analysis in DS-PAW software, thermodynamics, phonon you can do in the DS-PAW software, AIMD you can do, molecular dynamics you can do, and you can find the structure stability also. And here you can see the quantum chemistry software, which is a BDF software. Basically, BDF is a quantum chemistry simulation package. Basically, it's used for the electronic structure of atom, molecules, and density functional theory. It basically helps to predict electronic properties, band structure, charge distribution, and study molecular behavior, simulate chemical reaction, analyze optical and magnetic properties. You can see here, you can find the ground state to the excited state, single point energy, LDA-GG, meta-GG you can do. You can see the TDA, time dependent DFT you can see, and you can see the response properties to the time dependent DFT transition dipole moment also. You can do the structure optimization. You can include also Hartree-Fock theorem in the BDF software, and you can do the quantum chemistry to the BDF software. I show the BDF also, and you can see some of the example related to the BDF here, like analysis for the absorption here and natural transition orbit analysis also in the BDF you can do. You can see some of the paper have been attached to the BDF, like for the spin orbit couple computation. Same way, you can see the for the optimization for the corneal intersection and the minimum energy intersection you can see here. You can find like vibration frequency calculation and calculation for the large scale system also in the BDF. You can do the structure optimization with the spin mix state also. And there's another software which is MOMAP software, where you can find like photophysical property calculation and transport property calculation. Like you can find radiatory rate, absorption spectrum, emission spectrum, intersystem crossing rate, and in transport property calculation, you can include transfer integral, carrier mobility, electron transfer that you can do. You can see the sum of the application case here, like to explore the correlation between the structure of platinum and triple potential energy plane in order to achieve theoretical research for the phosphorescence quantum yield. You can see some of the paper also related to the MOMAP software. Here you can see some of the figure have been attached from the research paper, which is using through the MOMAP software. And it basically is used for the photophysical. You can use for the OLED, perovskite, and other material also. And here you can see the tight binding software, which is a nanoscheme software, where you can do for the device doping, and you can find transport calculation with the Slater-Costa parameters, and you can include like rescue Hamiltonian, and you can find charge density distribution, IB curve, you can find PDOS, LDOS, you can find. You can find electron transmission spectrum also, like this type of device you can create in a nanoscheme, and you can find transfer characteristics, band structure using the tight binding method. Here you can see for the tunnel field effect transistor, this type of devices you can create in nanoscheme using the tight binding method. And basically, we offer the several software for the DFT base and quantum chemistry software we also offer. And we offer on the cloud also and on premises also. You can see here. We can offer the software for the cloud also. It means you can simulate your example on the cloud also at cluster system. Basically, you can use multiple core like 128 core and 4 node. At 4 node, you can use 128 core. Let me show you the directly DFT-based software, which is Device Studio. I hope everyone downloaded a Device Studio.
Hello.
Yes, sir.
So for cloud-based computational simulations, how
Yeah.
much charge you are?
Sir, for the charge, sales team will contact with you.
Okay. Okay. Carry on.
Here you can see the Device Studio zip file. First, you have to extract the Device Studio zip file. After that, go to the extracted Device Studio zip folder. Go inside the bin folder of Device Studio, where you can see the Device Studio.exe application file. Double click to open. You can see in the different language, you have to click on EN to convert. When you go for the cloud license, it will give you user ID and password. Then you can go for the cloud here access. For the time being, you have to click on the offline and click on generate text file. Here you can see the license number text generated successfully. Click on OK, click on back and close this window file. You can see the here license number text file in the bin folder. What you have to do, go to the Chrome, type Nano Academic, go to the below section of this website. Here you can see the user portal. Click on this. If you have created your account, then sign in again. If not, sign up first. Here, click on the sign up. You have to enter your email ID, password, then sign up. Then confirm mail will come like this. You have to activate your account by clicking on the confirm my account. Then again click on the sign in page and log in with your details. After that, you have to update your profile here. Basically, give the proper information here like name, last name, title, and other information, and click on update. After that, go to the product section, then Device Studio. In your screen, it is show start a free trial. Click on start a free trial, and after that, it will show the activate button. Click on the activate button and upload your license file. Once you upload your license file, it will show like this. Download your license file. Click on this. Here you can see hjwtech.lic. Cut this license file and go inside the Device Studio folder. Here you can see Device Studio. Then in bin folder, paste the license file here. Here you can see hjwtech.lic file. Again, here you can see Device Studio.txt file. Double click to open the software. Click on English and you have to click on the offline. Now it will open your Device Studio software. I hope everyone created their open their Device Studio software. Please confirm so that we proceed further.
Yes, sir. I bundle.
Okay. Give the name of your project file. And click on save button. You can see this is a Device Studio GUI where you can create your material file, import your material file, and you can also simulate at single place. At the top section, you can see the menu bar, file, edit, view, build, simulator option you can see here, window and help. In the file option, you can see the new project. By clicking on this, you can create your new project, open your existing project. By clicking on the save project, you can save your project. For the new option, you can create your device, crystal, and molecule also. Through the import option, you can import your material file through the local database and through the online database also. In the few minutes, I'll show the how to import your material file also. In edit option, you can see undo and redo option. In the view option, you can see the toolbar, status bar, and other option also you can see. In the build option, you can see molecule, molecule 2D, interface builder, CAD to atomic, multiple build option given here. In the simulator option, you can see multiple simulator also given here, like nanodecal, nanoscheme, rescue, and DS-PAW. For your license file, it will show like nanodecal only, nanoscheme, rescue, and DS-PAW. In today's session, basically we go through the rescue and DS-PAW only. Windows section you can see, and the help section you can see here. Go to the file and click on import. If you click on the import, there is option for the import local and import online. Click on import local. Device Studio offer wide range of material database. Here you can see some of the material have been given here, like 3D material, organic material, 0D material, 1D material, and 2D material. If you go inside the 3D material, you can see the semiconductor, insulator, layer material, magnetic material, metal oxide, novelty material, and conductor you can see. In semiconductor, you can see multiple material has been present here. In same way, insulator you can see, layer material you can see, like MOS2, WSC2. Same for the magnetic material also, FeO, nickel you can see here, ZNO you can see. Same for the metal oxide, multiple metal oxide material present here. Novelty material. In novelty material, you can see the perovskite also, topological insulator, half metal you can also see. Like you can see some of the perovskite material also present. If someone working on the perovskite solar cell, you can find the properties also, like for the material, like their NK value, you can find here. Same way for the conductor, you can see. Same for the organic material. Zero D material. 1D material, you can see some of the nanotube with different Kroll vector. 2D material, you can see here. Here you can see the graphene material also. It means Device Studio offer wide range of material database also. Apart from that, if material is not present in the local database, you can import in other format also. Here you can see HJW, XYZ. In CIF format, you can also import. In XYZ format, you can import your own material file, postcard, contcard, SCF input, JSON file, molecule, PDB format. It means you can export, import your material file in this format also, like HJW, XYZ, CIF. Apart from that, HJW, you can import in XYZ, CIF, molecule, PDB. For a time being, let's import the graphene material from the 2D material and click on open. You can see the graphene material. I hope everyone completed up to here. Please confirm.
Yes, sir.
Okay. Again, I repeat, go to the file option. There is option for the import. Click on import, import local. You can see the wide range of material database which Device Studio offer, like 3D material, organic material, 0D material, 1D material, 2D material. You can see here. From the 2D material, you can see the graphene. Click on this and click on open. Apart from that, you can import in other format also, like XYZ, CIF, postcard, molecule, PDB, and other format also you can see here. Now you can see in the project section graphene.hjw, and you can see your structure also here, graphene structure. Again, go to the file, import. Now click on the import online option. Like if material is not present in the local database and your own system, you can directly write your formula here basically. Like if I type MOS2 and click on search, it basically fetches the data from the material project. Here you can see import from the material project. When you type your chemical formula, it directly fetch your material with the different space group. You can choose according to your need. And you can see the information related to the material file also here. You can see the like cell length, symmetry also, cell volume you can see. And click on add button. Again, I repeat, go to the file option, import, and there is option for the import online. Click on this. If material is not present in local database, and directly you have to type your formula or ID basically. Like if I type MP149, it basically fetch the data from the material project, which is open source. You can see it's import the silicon material directly. And you can see the information also, like for the cell length, other information also. And you can click on add button. It means Device Studio offers two ways to import your material file. First one through the local database. Second one through the import online option. There is third option. Go to the file, new, and there is option for the crystal. Click on this. If material is not present in the local database and online database, you can create your own material file through the crystal option. Here, what you have to define, you have to define the space group. You can see multiple space group have been present here. You have to choose according to your own material file, and you have to assign the brevis lattice also here. Like I choose 226 for the face centered, and I have to define the brevis lattice also here. Like I write 5.6, and I have to give the element also here. Click on the plus button. You can see by default carbon is selected. Double click. It will open the periodic table. Choose the element according to your need. Like I choose Na, and you have to give the fractional coordinate value also. Like for P1, P2, and P3, you can give the value also. Again, it's so Na. I have to change for the chlorine. And give the fractional coordinate value basically 0.5, 0.5, 0.5, and you can go for the conventional also, conventional cell, and click on the equivalent atoms. Click on preview. You can see the structure also like this. I take random value, that's why it's so like this. By defining the space group, Device lattice, and the fractional coordinate, you can create your own material file through the crystal option. Click on build. I hope everyone completed up to here. Please confirm so that we can proceed further.
Yes, sir.
Okay. It means there is three options to import your material file. First one is import local database. Second one is import online option. And the third one is the crystal option. So the crystal option, you have to define your Device lattice and space group fractional coordinate you have to define. Now let's see the build option. In the build option, you can see the molecule 2D option. Click on the molecule. It will open a new window for the molecule structure. You can see the molecule. Here you can see the plus button. Click on this to add atom. It will open a periodic table. You can see by default carbon is selected, and you can see the fragment also for the carbon, single carbon atom and different carbon fragment you can see here. Like if I choose tetrahedral, you can see the structure also here. If I want to change the bond length and bond, you can also do by clicking on this. You have to first select by clicking first atom, then second atom with the shift button. You can see, you can change the bond length also, bond also, like single bond, double bond, like this you can do. And you can, by fixing one atom, you can change the bond length also. Like I fix atom 1. With respect to atom 1, it will change the bond length. Click on cancel. In the same way, for the angle, you can also do like modify angle. Like in this same way, you can fix one atom, rotate also. And you can see, you can rotate in this way. Like if I fix atom 2, you can see here. In this way, you can modify the bond angle also. And click on apply data. At the right corner, click on apply data. In the toolbar option, there is the option force field. Click on this to minimize your structure, molecular structure. You can see the different algorithm. Click on GFF. It basically optimizes your molecular structure. It will take some time. Now you can see it optimize your structure. Again, go to the build option. There is the option for the molecule. Click on this. And apart from the add atom option, you can see here ring fragment also, multiple ring fragment like benzene structure and different structure you can see here. Same for the R group also, and biomolecule fragment also given here. You can see if someone working on the biosensor and the other parameter you can choose according to your need. Close this. Again, in the build tab, there is option for the molecule 2D. Click on this. You can directly create your molecular 2D structure also. Like here you can see the ring structure. And you can see the draw single bond. In this way, you can create, like if I have to replace this atom, I can also do. You can see here, choose element, click on this, and click oxygen here, and click on carbon to replace. And you can directly click on apply data. Now you can see the structure also here. To minimize, we have to choose algorithm. Now it minimize your structure also, molecular structure. Again, I repeat, to create a molecular 2D structure, click on this. Choose any fragment. Like to draw a single bond, different bond, you can choose according to your need. Here you can see draw single. Click on this. Click on corner. In this way, you can directly create your and click on apply data. I hope everyone completed up to here.
Sir, if I want to choose perovskite material,
Yeah.
then how can I choose, suppose, for example, MASN BR3,
Okay.
that is CS3 NH2 BR3 material. So how can I choose that?
Sir, you can look into the material folder basically first. If material is present in the 3D material, and in the perovskite material, you can see your perovskite material also. If material is not present here, what you have to do, go to the file, import and import online, write your chemical formula and search. If material is also present, not present in the online database, there is third option, new crystal, and here you have to define the space group, Brevis lattice, and their fractional coordinate of all elements to create your perovskite material.
Yeah.
And you can look into the research paper also for the material database also.
Okay, sir. Thank you.
If anyone doubt, please ask regarding the choosing the material file and other things. If anyone have doubt, please ask. Again, I repeat, to import your material file, go to the file option, import, and here you can see import local.
Hello,
and
sir.
Yes, sir.
How do you create a structure of AG dope SNS?
AG dope. First, sir, you have to import your material file, like directly present. You have to import AG material, and you can dope with the replace atom option also.
I have created SNS structure and I was trying to replace with the AG material.
Yeah.
But I don't know how to create with 5%, 10%, 15%. If suppose I have 40 number of atoms of SNS, then for 5%, 10%, 15% AG dope, how many atom I have to replace?
Sir, you have to look the theoretical part, like you have to find the percentage, how many number of atoms you have to replace. Like for the 15%, I think we have to replace 1 or 2 atoms for the AG. And like I show you also, like this is a graphene structure. If I want to replace any atom, first I have to redefine to create a supercell structure.
I'm sorry to interrupt. I just wanted to
Yes,
check
sir.
that how do you choose the appropriate position for doping? Like there could be a number of possibilities where a dopant can be, replaced.
Yeah.
So how do you make sure that the position that you particularly have selected is the best one?
So you have to find the property first, like related to that, and you can find according to property you have to change.
Like which property?
No, for that you have to calculate the formation energy and all. No? Once you get the
Okay.
formation energy, then you can just proceed with the calculation. Whichever location have
Generally,
the
like
highest energy.
how long does it take to calculate formation energy for all possible, dopant structure? Because like
It's
this is
simply
kind of
SCF
information
calculation
that
only.
produce. Uh-huh.
It's
Okay.
simply simple SCF calculation only.
So but SCF may take time to converge for a periodic structure.
Yeah, for bulk you have to repeat up to certain extent. No?
Mhm.
If it's a bulk, you need to have 3 by 3 by 3 or 2 by 2 by 2 and all. For monolayers and all, it's quite easy. It doesn't take much time.
Okay.
But for bulk, to maintain the dopant concentration and all, you need to have bigger supercell.
So is there a like linear relation between taking a smaller unit cell and then repeating it in X and Y and Z direction? So like is the relationship going to be linear? Like whatever formation
No,
energy
that
I
you have
get
to
for
check. That you have to
Okay.
check.
Okay. Thank you.
Welcome.
I think that is technical part. We have to go through the articles, journals.
Uh-huh. Okay.
Yeah.
Thank you.
Like in the build tab, I show the option for the graphene nano ribbon.
Hello, sir.
Yes, sir.
I have a question again in my mind. So
Yeah.
this DFT, does it include the scan functional?
Scan functional, sir.
Yeah.
Can you elaborate, please? I didn't get.
So this DFT based functional, it has like LDA, you mentioned LDA, then GGA, meta GGA,
Yes, sir.
isn't it? Even the hybrid functional as well, like M06 and so on.
Yeah.
So does it has scan functional included in it? That's my question.
Sir, I have to check. Then I'll let you know, sir.
Sure. Yeah. Thank you.
Like this graphene nano ribbon, I have to replace any atom to create doping effect like this. I have to select any atom, and there is option you can see here, replace atom. And you can replace with any atom like nitrogen and any element. And you can create doping effect also. This is the first way. Apart from that, you can also do in the simulator nanodecal virtual crystal approximation. You can see the doping type, like for the P type and N type you can do. And there is option for the mixer atom. Like here you can see the composition also you can give here. Like 0.75, 0.95, and you can add another element and you can choose. There is multiple way to create a doping, like by replacing the atom, and there is option for the P type, N type doping, and by composition, by giving the value for the different element, you can create a doping effect also.
Is there any option for functionalization of these nano ribbons?
What, sir?
Functionalization, passivation, like this ages, no, where we can passivate with hydrogen or halogen.
Yes, sir, you
atoms.
can do the passivate with
Yeah.
hydrogen also. What you
Yeah,
have
is
to
there
do,
any option for that one?
select all atoms, and
Mhm.
there is option for the hydrogen passivation. You can see here. Click on this, and it will passivate the with the hydrogen atom.
Okay, thank you.
Again, I repeat how to create a graphene nanoribbon structure. Go to the build option. In the build option, at the below section, you can see the graphene nanoribbon. Click on this. It will open a new window with the name graphene nanoribbon. You can see for the side A, carbon is selected. In the same way, for the side B, carbon is selected. To choose different element, you have to click on this. It will open the periodic table. According to your need, you can create different element nanoribbon structure also. Same for the side B also. By default, there is carbon selected. Let's go with the by default one. And you can see that you have to assign the bond length here, like 1.42 angstrom. And there is option for the passivate dangling band with the hydrogen atom here. You can click on this. And by defining the N and M, like to create zigzag graphene, armchair graphene, you can create through this. And click on preview. Here you can see it passivate with the hydrogen atom. If I click uncheck this and again click on preview, you can see it not passivate with the hydrogen atom now. What you have to do, click on the build tab. Now you can see your graphene structure here. To create a supercell structure, go to the build option, redefine crystal, and you have to define the 10 here value. In the redefined crystal, you can go for the face centered also and the body centered also. Click on the preview and click on build. Here you can see your graphene structure. I hope everyone completed up to here. Please confirm. I'm audible.
Yes, sir. Yes, sir.
I hope everyone
Yes, sir.
completed.
Yes, sir. Yes, sir.
Okay. To see in the different view, you can click on the home icon. You can see XY view, XZ view, YZ view, YX view, and ZX view. And if you want to passivate with the hydrogen, what you have to do, left click of the mouse, drag a box, and select all atom. And there is option for the hydrogen passivation. Click on this. And if you want to delete any atom, you can also do like select, and there is option for the delete atom. In the same way, you can delete also the atom here. And if you want to replace any atom, what you have to do, click on any atom, and there is option for the replace atom option. You can replace with any atom. And you can see the color also different here. For the here you can see oxygen. If I click on this, you can see the Cartesian coordinate also. In this way, you can create a graphene nanoribbon also. And there is option for the graphene nanotube. If I click on the graphene nanotube, here you can see in the same way for the nanotube structure, side A carbon is selected and side B carbon is selected. To choose different element, you have to click on this and it will open the periodic table. Go with the 2x2 this time and click on preview. You can see here and click on the build tab. To create a supercell structure, go to the build option. There is option for the redefine crystal. Give the value here in the seed 10. And you can see the supercell structure for the carbon nanotube. Click on build. Again, go to the build tab. Go to the graphene nanotube. Now you can choose different element also, like nitrogen. Same for the side view also. And here you can give the value like 5. And click on preview. Here you can see the nitrogen nanotube structure. And click on the build tab. To redefine, again you have to go to the build. Click on the redefine crystal and give the value here 10. Click on preview. You can see the nitrogen nanotube structure. And you have to click on the build. Here you can see nitrogen nanotube. Like to create a concentric nanotube structure, what you have to do, go to the 2x2 nanotube structure, carbon nanotube. Left click of the mouse and select all. Right click and there is option for the copy. Click on copy. First click on the home icon and click on the paste file. Right click and click on paste. Again, you have to select only carbon nanotube by left click of the mouse. And there is option for the center. Here you can see center. Click on this. This type of nanotube structure you can create in the Device Studio GUI also. I hope everyone completed up to here.
Okay.
Let's simulate a graphene structure. Click on the graphene one, this one, because there is only 2 atoms. It simulates fast. Go to the simulator option. Here you can see multiple tools have been given here. For the material base, you have to go to the rescue software. You can see the rescue. And you can see here SCF calculation. You can also relax your structure. If you want to relax your structure, click on the relax. In the relax, you can see exchange collision function also, like LTA, GGA, Wonder Wall also you can see. And you have to define the method also, like real space and LCO, linear combination atomic orbital. And in relax method, you can assign like cosine Newton, conjugate gradient, Stephen descent also, iteration control, basis set. In the basis set, you can see here LDA plus U. You can also include Havardu term. And in the basis set, you can also define user defined also given here. By clicking on this, you can choose pseudo potential from the database also. You can see here multiple pseudo potential given here. Rescue atom database, neutral atom database. For a time being, let's go with the default one, atomic data. In the spin type, you can see collinear spin, journal spin. Like to find the magnetic properties and other parameters, you can go for the journal spin, collinear spin. And you can also include spin orbit interaction also if you want. For time being, let's go with the no spin and click on generate file. Here you can see in the left section in the project pipeline, you can see it created the graphene folder. Then in graphene folder, you can see the rescue crystal folder. In rescue crystal folder, you can see two input files, rescue crystal and atom.xyz. In atom xyz, you can see the Cartesian coordinate of your input file, basically for this graphene structure. Like if I click on open with, you can see the coordinate for your carbon structure, Cartesian coordinate for the graphene. And if I click on the relax.input file and click on open with, you can see the script also for the relax.input file, which is created through the GUI. Here you can see the calculation type, relaxation, and where it will save your result file in the info save path in the result folder. And you can see the other parameters also, like exchange correlation function, spin type you can see, and from where it will take the pseudo potential database. Here you can see, and Cartesian coordinate. You can see the atom xyz from the atom.xyz from here. Click on save. You can also edit here if you want, like to change the grid value, sigma value. You can change here and click on the save. Right click and click on the run option. In the job manager, you can see the relax.input file in running condition. You can see your process here also by clicking on this. It not started yet. For the time being, let's generate the SCF input file also. Go to the simulator, rescue, and there is option for the self-consistent field calculation. Click on this, and you have to give the value here for the sigma also, like in electron volt. Method you can see real space and linear combination atomic orbital. Exchange correlation function you can see. Here you can see the multiple exchange correlation function have been given, like LTA, GGA, hybrid function you can see here. HS06 you can see here. Multiple exchange correlation function have been given here. Meta GGA you can see here. For the timing, let's go with the default one, LDA. And in iteration control, you can see the tolerance level for the charge density, total energy, and the mix method you can see here. In the basis set, you can also include Havardu term if your element is rare earth element, transition element. You can click on Havardu term and you can give the value for the d orbital and f orbital. And check this. And in spin type, you can see here like collinear and general spin. Same for the relax like. And click on generate file. In the same rescue crystal folder, you can see the SCF input file also. Right click, open with, and you can see the script of your SCF input file for the graphene structure. You can see the calculation type, save path, and other parameters also, like K point, unit energy, grid, and other parameters. To change some value, you can also do in the script also. And after changing, you have to click on the save button. Let's run the SCF input file also. Right click, click on run. In the job manager, you can see your SCF input file in two conditions. First, it will complete your relax.input file. After that, it will run your SCF input file. For the time being, let's create an input file for the analysis also, like band structure, DOS, and other parameters also. Go to the simulator, rescue, and here you can see the analysis. Click on this. You can see, you can find density of state, band structure, molecular potential you can find. If I click on the band structure, by double click, you can select your calculation, and you can see the parameters also here, like symmetric K point. If you want to change the path, click on the path. It will open the Brillouin zone path. Here you can see. You can also edit if you want some value to change. You can also do like this. And you can also, if you want to delete, you can also do by doing this delete button tab. And you can move up and bottom also to this arrow. Move up and move down. And you can add new point also if you want. After that, by changing, you can click on the preview, then click on apply. Again, select density of state also. Click on density of state, double click to select. Here, click on this density of state to show the parameter to change, like K point sampling. You can assign the energy range also. Like if I give here, go for the 5 cross 5, minus 5 to 5. And you can see the number of energy point, K point sampling. According to your material file, like semiconductor, insulator, you can choose the K point sampling method also. And click on the generate file. In the same rescue crystal folder, you can see band structure.input file and density of state.input file. Right click, open with. Here you can see the script also, calculation type, band structure, and the path of your result will be saved in the result folder. If you want to see your result here directly, what you have to do, remove the result and give the name like this. Remove the result from the save path. It will show the result directly here. Click on save after editing and close this. And right click, click on run. Same for the density of state. Right click, open with, and you can see the calculation type, DOS, and where your result will be saved in the result folder. To see the data directly here, remove this and save and run your density of state input file. Here you can see band structure.input file in running condition and density of state in queue condition. And you can see the relax.input file also completed and SCF input file completed. Here you can see it created a rescue log.out file. Open with, you can see it shows the whole process, how it started, like calculation type, pseudo potential, resolution. You can see the iteration step. Here you can see the iteration step also, and local forces, co-correlation function. After that, it will started the self-consistent calculation. You can see here, beginning self-consistent calculation. And it will simulate your iteration step. And after that, it will simulate your band structure file. Here you can see. For the band structure also. Here you can see in the project section, it created the band structure.txt file, density text file, and density of state text file. Right click and click on show view. You can see the band structure for the graphene. And like to change the value here, K point path, what you have to do, from the band structure.input file, you have to copy the symmetry points, and in the text file, open containing folder, you can see the band structure.txt file. Right click, open in Notepad. At the exclamation mark, you have to paste your K point here, and it will show the result in proper way. for the band structure. You can see the density also in the 3D model. You can see the spin up and spin down process. 2D you can see. You can see the average along y-axis also, z also. And you can change the spectrum also, like color map you can change. And you can see the stereoscopic display. Same way, you can save your 1D plane also, like for the XY plane, YZ plane, and XZ plane. You can export in the image format also. You can see multiple image format has been given here. And you can see here density of state text file, right click, show view. You can see here -5 to 5. And you can export in the multiple image format also. For up to now,
How to visualize the relaxed structure?
what's up?
How to visualize those relaxed structures? Like I can't see the option there.
Like if I right click, you can see the show view option. It will directly show the band structure you file.
For the relaxed structures.
Okay,
After
for the
relaxation, no, we get the relaxed structure.xyz. How can we view that one?
go to the file option, import local, and go to your project path. Basically, you can see here rescue first. Click on this graphene rescue crystal, and you can see the relaxed
Okay.
structure.xyz.
We can't directly view from this terminal, right? We have to go back again.
Yes, sir. From the import, you have to import your material file. And in rescue, basically,
And
it optimize the atom position, not the cell.
Mm. So there is
I
no
don't-
option for that one. Yeah,
What,
for
sir?
2D optimization. For 2D optimization, no? Like
Yes, sir.
there are different ways which we can do. Like for
Like-
along C, we can fix it, then we can relax along A, B, and all. So
Like if
that
you
kind
want
of
to
option is here, like constant relaxation. What I meant is constant relaxation, like keeping the lattice C fixed, then A and B, keeping it free.
yes,
No?
sir.
That way.
Yes, sir. You can do this. Like fix some atomic position. Also, you can do in the relaxation also.
Not
I'll show
only not atomic positions, but the lattice side, no, A, B, and C. In quantum
Yes, sir, I'll show
expression and
you.
all, we do 2D free and all, something like that. Is there an
Simulator.
option for this? That one?
Yes, sir. If you go into nanodical software, there is option for the relax. If you click on the relax, you can see fix central cell shape. You can fix also. In the nanodical software, you can relax your
For
unit
2D,
cell.
we need more. Yeah.
What, sir?
For 2D structures, we need more freedom, no? I think we have to be careful while relaxing the 2D structure with this method. I think.
Yes, sir. In the rescue folder, in the rescue software, you can only do for the atomic position. But for unit cell, you have to go to the nanodecay and relax your unit cell plus atomic position both. And you can fix also. I show in the documentation also.
If you do this, yeah. If you do this way, then the vacuum can collapse, no? For 2D also. So that will be a problem, I think.
In the documentation tutorials, there is option. Here you can see the documentation for the relaxation also for the in RESCU software, how to do the relaxation. But in the RESCU software, you can only do for the atomic position, and like for the nano decay, I'll show you. Here you can see the structure relaxation. You can do through the molecular dynamics and conjugate gradient. And you can see here fixed center shape also. And you can apply like constant pressure also, like this. You can see here constant calculation, relaxation, constant group 1D. So this way you can relax your structure also, like the thing you asking.
Yeah, I'll check that one. Thank you very much.
I hope everyone completed up to here. For the graphene structure, you can find band structure and other parameters. Please confirm. Okay.
Yes, sir. Completed.
Like again, go to the build tab to see the other parameters also. In the build tab, there is option for the interface builder. Click on this interface builder option. And you can see here the like structure A and structure B option given here. Click on this three dot to import your material file. In the material folder, go inside the 3D material, conductor, and let's choose silver. Same for the structure B also, choose different element. Like let's go for the gold here. And you can give the surface order in different direction also, X, Y, and Z. And you have to assign the grid size to create a supercell structure. You can also define the rotation and the strain range also, like for the first surface, second surface. And you can click on the match to create the interface between gold and silver. Click on preview. And you can see the structure for the interface between gold and silver. And you can see the properties also here, atom number, mismatch percentage, you can see here, strain theta, and you can see area also. And click on build tab. Like this, you can create the interface between two different material file also. Again, I repeat, build, interface builder, and through structure A and through structure B, you can import the material file by clicking on three dots. And if your material is present in here, you can directly, by clicking on this, you can select, like for graphene, like create a twisted bilayer graphene structure, like Mori pattern and different type of pattern. You can also create.
So can I create dislocation lines?
What now?
So dislocation lines, can I create dislocation lines? Like there are different type of defects like line defects, point defects. Can I create dislocation lines?
I'll show you, man. Wait. Here you can see the atom number also, the mismatch percentage. By clicking on any blue dot, you can change the, you can see the other parameters also like mismatch percentage. You can see the structure also changes. And in the extreme range, you can change like surface also, first surface, second surface, and both surface. And click on preview. And you can create this type of graphene structure also, like bilayer graphene structure. You can see the different type of pattern you can create by using the interface builder option to the rotation option. Again, in the build tab, there is option for the CAD to atomic. Like if you want to create a 2 or more material interface, you can also do by clicking on this add rectangle and click on the calculation. What you have to do, you have to give the structure file here. Choose from the material folder. I choose only gold silver because due to the small lattice mismatch. For the second structure, and for the third structure, again you can choose the gold. And you have to define the gate size here and the length also. And after that, click on preview. You can create this type of structure also through the CAD to atomic option and click on build tab. And like to create a device structure, there is option here, convert to device option. Click on this. And here you can see the left electrode option, right electrode option, bottom electrode, top electrode, front and back electrode. Click on left electrode, right electrode. You can see the electrode dimension here. You can also change if you want. And click on the preview. And click on the build. In this way, you can create a device structure also. Like if you want to create the flexible devices, click on the build. And you can see the bending of device here. By giving the model here, like one-sided, both sides, and theta value, you can bend your device structure also. Like for the one-sided also you can do. And for the both side you can also do.
Is this blend option only for device, or we can just use for other materials also, like planar materials also?
Sir, is only for the device, bending of device.
We can't rotate the layers and all, right?
Sir,
Twisting is not there.
You can do, sir. I'll show the for the crystal structure also.
And also, is there any option for the termination, like selection of the termination? Here you just use AU and all, no? But if I have central region as magnesium oxide and all, so in that case, if I want to terminate left electrode with oxygen instead of magnesium and all, is there any option for that kind of thing here? Like while we
Yes,
are
sir.
building the interface?
Yes, sir, you can do. Like I choose because due to a small lattice mismatch,
Yeah.
what you have to do, file, new, device option. You can choose the structure here, like left, right structure, left, center, and right, bottom and top, bottom, center, and top electrode, front and back electrode, front, center, and back electrode. Like if I choose LCR here and click on OK, you have to give the left electrode material file, center electrode material file, right electrode material file, and you have to give the length here. Then you can create any device structure like ZNO, MGO, the thing you can say. So the file option.
hello, sir. Hello, sir.
Yes, sir.
Yeah, sir. When I giving the dimension of the left electrode in Armstrong, sir, it's showing that warning of the left electrode extending vector is invalid. Sir, why this warning is showing in the interface?
Once you create this type of structure interface, when you go to the
Okay, sir.
convert to device option,
Okay.
left electrode, right electrode, and
Yes.
if you want to change the dimension, you can also change and directly click on the preview, and you can build also.
Okay.
Sometimes
Okay.
it is,
Okay.
if you go for the top and front, it will show error because your structure is not this plane.
Okay.
And like for the structure, you say for this structure, if you want to move or rotate also, you can also do select, and there is option here you can see move atom. You can move your atom in any particular direction. You can see here. And there is option for the rotation also. Like this, you can rotate also at particular angle. By defining the angle, you can rotate also for the crystal also. The thing you are asking for the rotation and other thing, you can do for single atom also, and for whole atom you can also do. I hope everyone completed up to here. If anyone have doubt, please ask. Okay, let me show the other feature also. In the build tab, you can see the nanotube also. Like to create a nanotube structure of any material, like if I import MOS2 from the layer material, here you can see the multiple MOS2. Select, left click of the mouse and delete. Again select and click on the center button. Go to the build tab. There is option for the nanotube. You can create this type of nanotube structure for the different material file also. By import your material and by clicking on the nanotube. Same for the different for the nanowire also you can create, and nanotube and graphene like structure, disorder graphene like structure you can create. Again, let's show in the rescue crystal folder. Click on open containing folder. If you see here, you can see that mat file also present. Because rescue written in MATLAB and C, some dependency on MATLAB also. To see the data related to the DOS and band gap and other parameters, you have to move to the MATLAB to see the value also, like for the MAT, band gap, Fermi level, and other parameters. In the same way for the band structure, you can see graphene ds.mat file. Like to find the parameters for the optical, phonon, and other parameters, you can also do in the rescue software. I'll show you using the density functional perturbation theory. Let's import any material file from the 2D material. Let's import boron nitride and click on open. Here you can see the boron nitride structure. If I go to the simulator option in the rescue, there is option for the density functional perturbation. And you can see in the task, it's selected phonon band structure calculation. You can see, you can choose any parameter like Raman property calculation, phonon band structure, and phonon density of state calculation according to your need. Like if I click on optical property calculation, you have to define the parameter here, like SCF method, real space, K-point sampling, tolerance, spin type, and you can see the in the optic you can assign the damping factor and electric field direction. And click on the generate file. Here you can see it created the folder HVN, then rescue crystal. In rescue DFPT folder, you can see the SCF input file, dielectric.input file, phonon.input file, optical.input file. Basically, in density functional perturbation theory, it created through the perturbation using vibrational, using phonon properties, and through the electric field, through the dielectric.input file. You can see here. First, you can see the script also. Right click, click on run. Same for the dielectric. First, you have to run the SCF input file, then dielectric.input file, phonon.input file, optical.input file. Right click and click on run. And in tomorrow's session, basically we go through the DS-PAW software. Here you can see the DS-PAW. In DS-PAW, you can find NAB method, AIMD, vibration, and analysis plot. Here it shows the whole process here in the Device Studio GUI. For the post processing, it will also give the post analysis tool for the DS-PAW software. Like in the DS-PAW software, you can do multiple things. You can include like a cutoff factor. You can include the van der Waals, hybrid function. You can include column interaction. You can include And in advanced option, you can include also background charges, hybrid factor, dipole correction, fixed potential you can do. You can also include solvation model you can also do. In tomorrow's session, we go through the AIMD also, NEB, and other parameters also, like find a partial charge, molecular potential, and other parameters. Here you can see for the boron nitride. To see the graph for the boron nitride related to the optical property, you can see here. You can see the dielectric permittivity we generated through the rescue software. IR intensity, energy loss, and we also find the phonon band structure, phonon DOS, and we find also the properties for the Raman in previous project. Same here you can see Raman intensity. Here you can see. And let me show you some of the other projects also which simulated earlier. Like for the scanning tunneling microscopy, we find through the rescue software. You can see some of the mat file here also, like the for the STM post.mat file and CLDA team.mat file also you can see here. You can see here dielectric permittivity for the different material also. IR intensities, IR spectrum, refractive index. To find like figure for the dielectric and other parameter, you have to switch to the MATLAB for only DFPT parameters to see the graph only. For only DFPT, you have to move to the MATLAB to see the graph. It will not show the graph here. I hope everyone completed up to here. If anyone have doubt, please ask. You can write in the chat box also. You can see it Device Studio GUI for the other software also. Like you can see here, it also give the GUI for the WASP. It only offer the GUI, not the background engine. Same for the Quantum Espresso. It offer the GUI only for the Quantum Espresso, Gaussian, and WCGM. For these software, below software, we only offer GUI, not the background engine. And above all this software, we offer the background engine also, like for the NanoDecal also, NanoScheme, Rescue, DS-PAW, and you can see the PDF also, MOAB also. Yes, you will get the recording session of this.
Sir, what is the price of this license of this software?
Such sales will to team coordinate with you
Okay,
regarding
okay,
the
sir.
sales.
Okay, okay.
And if you have any query, you can send us to mail on the support@impress technology. We also send in the chat. You
Okay,
can directly
okay, sir.
contact us.
Okay, okay. Thank you, thank you, sir.
Anyone have doubt, please ask regarding the material import and other parameters, like finding the parameters, relaxation, SCF calculation. Yes, ma'am. In this license, you can use the nano decal also, rescue, DS-PAW, and nano scheme. 4 software you can use in this license file.
Okay, sir. Thank you.
Hello. Hello, sir.
Yes, sir. Yes, sir.
So DS-PAW, what is the difference? Can you tell me once again the
Yes, sir.
difference, advancement of the DS-PAW as compared to the ST?
Sir, in rescue software, it is based on density functional theory and density functional perturbation theory. It is based on KSDFT. And
Yeah.
in DS-PAW is based on the plane wave, plane PAW algorithm. Basically, it is a competitor of WASP. DS-PAW is a competitor of WASP, where you can use
Yeah.
for the finding the other parameters like NEB, AIMD, solvation model, and other parameters also.
Yeah. So particularly which, whether it is functioning with MATLAB output or
No, sir.
Python output.
In DS-PAW, basically it will show your result in the JSON file and H5, and the two format is it will show in the output JSON and H5. And there is no dependency on other tools in the DS-PAW.
Oh, it has an inbuilt function, sir.
Yes, sir.
Okay.
Sir, can we create heterostructure by using this software?
Yes, ma'am. You can create heterostructure also through the interface builder and through the CAD to atomic tool option.
Okay. Okay. Can you show me one demo by using two materials?
Yes, ma'am. I'll show you.
Suppose MOS2 and GAT like this.
Okay. Build interface builder, and there is option for the structure A and the structure B. MOS2.
Okay.
And for the second material, what type you choose?
Suppose GATE.
What, ma'am?
GATE. Yeah,
Ca-
HB, graphene also we can use.
Okay. You have to give the grid size to create a supercell structure.
Okay.
According to the value given, it will create a heterostructure.
Mm, okay.
If
This
you increase,
preview version or we can build.
ma'am, through the preview option, you can see the graph here, and through the build, you can directly import here.
Okay.
And through the grid size and other parameter, you can check the mismatch percentage also and create a better heterostructure also.
Okay. After that, we can analyze the band structure, DOS.
Yes, ma'am, you
This
can do
property.
through the
Okay.
rescue option. You can do as first you have to do SCF calculation, and after that, go to the analysis. There is option for the density of state. In the density of state, you can find LDOS also, PDOS also by clicking on this projected and LDOS also.
Okay. And if you want to create some device structure by using this hetero interface, we have to use NanoDecal software.
Yes, ma'am.
Okay.
First, you have to
Okay,
convert to
thank you.
device option. There is option for the convert to device.
Okay.
You have to create first left electrode, right electrode, then you have to convert to device. Then you can go through the NanoDecal software.
Okay. 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 Thank you so much.
So is it possible to do charge density differential mapping as well in the heterojunction that you have made right now?
Yes, ma'am. We can do the differential charge also. Let me show you the direct example for the differential charge.
Can you just go to them?
Like we created for the boron nitride, and we let me show you the result directly for the differential charge using the NanoDecal software. We created with a different frame. For a differential charge for the boron nitride using NanoDecal software.
So can I do it in a heterojunction?
Yes, ma'am, you can do, but it will take some time.
Okay.
Yeah, can you consider a different passivation layer?
What, sir?
Different passivation layer can you consider here
Like
in
this.
multi-layers?
So
In
hydrogen
multi-layers.
passivation.
Different passivation in multi-layers heterostructure, I think.
But for the like hydrogen passivation, it only work for the silicon and carbon.
So suppose we will consider in the perovskites also. So
Yeah.
different passivation layer can you consider for different? Suppose we will consider in multi-layers. So
Yes, sir, you can create a
you-
multi-layer structure also through the CAD to
Yeah.
atomic option.
which option?
Yes, sir. In the build tab, there is option for the CAD to atomic.
Acha.
You can create multiple layer structure like this, and after that, click on the calculation, and you have to assign your material file here, and you can create a heterostructure type of layer. Like in the stack layer, you can see in the solar cell softwares.
Yeah.
You can create in horizontal way or vertical way, in both way.
Okay. So with the same electrode choice.
Yeah. But
yeah.
lattice mismatch will be less. Then it will create your heterostructure.
Yeah.
And in tomorrow's session, basically we go through the partial charge, border charge, and other material properties also through the DS-PAW software.
Okay.
Is there any way to construct a stacking configuration here?
What's that?
Different type of stacking configuration. No, in interface builder, I can see that the method that has been used here is kind of coincidence lattice matching method. No?
Yes, sir.
Those vectors, I think it's coincident lattice matching method.
Yes, sir. Like if
so when we see those stacking structures and all, they have different kind of stackings, no? A, B,
yes,
A,
sir.
and all. So as per what I've seen from your demo is we can duplicate the layer, then we can just move as per our need. But is there any other way through which we can create different kind of stacking configuration? like directly when we are building the heterostructures?
Yes, sir, you can like for this graphene nano ribbon, I'll show you. Like in this way, you can directly copy the whole sheet and paste to the other material also, and you can directly move button, and you can create your own heterostructure type of structure directly by stacking and rotation. Like in this one, you can copy one layer, and you can paste also. Like here, you can see 3-layer structure. In this way, you can create for different material also. And if there is lattice mismatch, you can also do through the convert to crystal option. You can match your crystal like hexagonal by defining the unit cell vector also. Here you can see user defined, and you can lattice mismatch, and you can create your heterostructure also. Anyone have doubt?
Thank you, sir.
No, ma'am, you can not get the solar cell properties here in this software. For solar cell, we have different software like SetForce and Laos, which is used for the solar cells, like for the perovskite OLED. Here you can only simulate for the material and for devices and quantum chemistry softwares. Thank you everyone for joining this session. In tomorrow's session, we go through the DS-PAW software, where we do the other parameter relaxation, where you can find AIMD, NEB, and other parameters. If
Thank you.
anyone have
Thank you.
doubt, you can go through the documentation also in the Nano Academic. You can see the documentation portal also. And you can also go through the YouTube channel of Impulse Technology, where we created a multiple playlist for the all softwares. Thank you everyone. Please join the tomorrow session.